Okay, yeah, it's from it. Okay, so this question 14, is about histograms. Now, these histograms, in order to work out histograms, we really need frequency densities. Frequency density is the frequency, which is this, how often something occurs, divided by the class width. Now, I have set up 2 extra columns to make things easier for myself so that I can work it out. But you need those 2 things in order to work out the frequency density before you can even complete this. So, let's start with the class width here. From 100 to 200, the class width is 100. From 200 to 300, class width is 100. 200 to 350, the class width is 50. Here the class width is 50. Here it's 100. Here it is 200. So you can see why frequency density is useful. Because if a class width is different, if it's not all the same, then that's going to affect how many people fall into that category. If the category is smaller, it's less likely that a lot of people will fall into it. So you really need to understand the density of a frequency so that you can make proper comparisons. You can control for the fact that there might not be as many people in it because it's a smaller category. So now let's work out the frequency density. So frequency divided by class width. So that's 1 divided by 100, so that's 0.01. That's 9 divided by 100, that's 0.09, or 9 over 100. So this is 10 over 50, which is just 1 over 5, which is 0.2. This is 8 over 50, which if we multiply up would be 16 over 100, so that would be 0.16. This is 2 over 100, which is 0.02. This is 3 over 200, which would be the same as 1.5. I know you're not supposed to use decimals, but just for this one time, over 100, which would be 0.015. Okay, now we've got all our frequency densities. Now we can make this scatter graph. I've come back, I've just started things off so that I can use one hand to do the rest of it because I'm holding the camera with the other hand. Now, the first 3 have been done for us, which is useful. Now we just need to look at the last 3 up here. Now, remember before when I told you, let's zoom in, that you need to look out for these sections here. So this is 0.5, so this is a set of like 5, but there's 10 in it. So that means that each 2 must be a 0.1. So this must be, 0.16, 0.17, 0.18, 0.19, and then 0.2. So I've gone 2 squares up for 0.16, and now I can go down and close my graph. Here again, the next one is 0.02. This one is 0.01, which we know because that's what the first one is. So 0.02 must be another 2 up. And now I close it. The final one is 0.05, which is right on the line. And remember to go to the class intervals. So this was 350 to 400. This was 400 to 500. This one is 500 to 700. So you make sure you go to the class widths. And you close that. So, here we have completed the histogram. Person thinks the median of these prices is 350,000. Explain why he's wrong. Right. So, we know the median is the middle value of all the numbers. So let's add up all the numbers in this small town. 1 and 9 is 10. 10 and 10 is 20. 8 and 10 is another 10, so that's 30. Plus 3, so we've got 33 houses in this small town. So the median number, right in the middle, we add 1 for 34, and we divide it by 2, so 17. So 17 is the middle number. So 1 and 9 is 10. This is 20. So we know that within this bracket comes the median number. So at least we know that he's looking at the right bracket. But here's where Jason is wrong. When we're dealing with class intervals, we don't just take the highest figure. We take the median value of the class interval. So we'd be looking at 325,000. So now we just need to explain that here. I have given an answer where I have said, though Jason is looking at the right row, 33 plus 1 over 2 is 17. And that is the third row, row 3. He forgot to take the median value of the class interval, so it's 325,000. So that is a way that we can answer that question. Finally, the mean price of these houses is 340,000. Find an estimate for the number of these houses with a price less than the mean price. So, and remember, they say estimate. Now, we know that the mean of these houses would fall into this category right here. So we know that these two houses, these two sets of houses are definitely under the mean. So we know so far, so we can say so far we have 1 and 9, so we have 10 houses. Now, we need to look within this category. Of 50, we've got that there's 10 of them. We know that the interval goes up to 350,000. So the mean, which is 340,000, which is 40,000 in from the bottom number, is 40 over 50, i.e. 4/5 of the way in. So we can then say we're going to use 4/5. Yep. 4/5 of that number.
Today are you doing maths?
Yeah. We're done with statistics coursework. I'll come and proper maths. We're done with statistics. So I'll come and find you after lunch and we'll do proper maths. Are you leaving after lunch? Exactly. What time is it now?
But look, you're snaking me.
Okay, one second.
12:07.
All right, let me stop this and let me do. Do you want to do it now or do you want to do it after lunch?
I'm going after lunch.
But you agreed to do it after lunch.
Yeah, but I forgot that I was leaving.
Oh my days. All right, 1 second.
No, man, I'm talking.
So 4/5 of 10 is going to give us 8. So with the 10 and with the 8 together,
When you start, you know what I mean? All right,
we have 18. So we can say approximately 18 houses, that 18 houses fall within or underneath the mean prices of 340,000.